Hello everyone and welcome to another video. In this video we would like to show you how to install the LVDT distance add-on for the CompreCell Pouch. On the bottom we have the front side sensor holders for the LVDT sensors. There are two parts, the sensor holders and the deflectors and a few screws. First I will install the sensor holders. There are two alignment pins that fit into the CompreCell. Then we need an M5 screw to fix the part in place. Last we have to insert the head screw that we use later to fasten the sensors. Now I will repeat the same process on the left side of the cell. Now we have to move on to the deflectors. They have a similar design, but they contain a steel mirror that will push against the sensor probe. Next we have to move on to the back of the cell. Here we need the sensor holders and a 2mm hex key. I have to reach around the cell to reach the back side. When the CompreCell is installed in the CompreDrive, this is a little bit difficult. You can make your life a little bit easier when you install the sensor holders with a cell that is not already installed in the CompreDrive. I will start with the bottom sensor holder. And then we will move on to the top deflector. In order to communicate with the computer, we use a device called Multi-Data Sampler. It has 4 ports for sensors. We only need 3, but there is a 4th one for future extension. And it is powered by a 24V DC and communicates with the computer via a serial connector. So we'll just go ahead and connect the power supply and the serial wire and connect the sensors. After switching on the device, we recommend to run it for 20 minutes in idle, because the sensors have a little power consumption and will slowly heat up. Now we want to connect the multi-data sampler to the computer. We will start the distance server application. And CompreDriveControl is already running in the background. We have to navigate to the MDS LVDT tab and refresh the device list. In this case, there's only one serial connector, so we can directly go ahead and connect the device. Here we see that 3 sensors are connected and out of range, which is shown by the red arrows. Channel number 4 is not connected and we don't need it. We move to the device settings and disable channel number 4, and we will set channels 1 to 3 to the appropriate voltage range for the sensors, which is 10 volt. After clicking apply, the settings are accepted. Once you have installed all the sensor holders, it is time to close the CompreDrive and start the approach procedure. It is time to install the sensors. Open the CompreDrive and use the LVDT sensors that I've already prepared here. I'll start with channel 1 and insert the sensor into the sensor holder from the bottom and press it against the deflector. For this process, it is important to monitor the sensor signal on the computer screen to make sure that the maximum working range is not exceeded. Once a signal of approximately 90% is reached, I will tighten the sensor in place by using the fastener here. I will repeat this process with the other 2 sensors. And for the last sensor, I have to reach around the assembly again to reach the backside sensor holder. Now that the setup is fully assembled, it is time to retract the CompreDrive to be able to insert a cell. We will now install a cell, and we will use this mock-up cell here as a demonstrator. With this very large cell in place, the approach procedure should show that the LVDT sensor signal is now at the bottom end of the working range. In order to calculate a correct dilatation value, it is important for the RHD distance server to know the geometry of the sensors. For each setup that we ship, there is a preset that you can use in the software. First, I'm going to select the 3 sensors that we are using here in the drop-down menu. And it is important to assign the sensors to the correct channels here. Afterwards, I will select the preset value for the geometry. In this case, I have used the CompreCell Pouch 331.3. So I have to select the channels here, and I will double check that I have assigned the right vertices. And with this geometry setup, the RHD distance server will be able to calculate correct center dilation value for the cell.